Okay, Sur-Ron battery pack building. You're thinking about tackling it. Do-it-yourself Sur-Ron battery pack. Hopefully in this video I can answer how to do it, how much it's going to cost, or in other words, how much savings you can get from doing it. Should you even do it? What are the pros and cons of doing it? And I'll go over all the trials and tribulations and fun I've had making my own Sur-Ron battery pack, 80 volt. But the same process obviously will work if you're doing 60 or 72 or 80. But I recommend if you're going to go to the trouble and do a whole new battery pack, definitely do 72 or 80 volts. You do not want to stick with 60 volts of stock. More volts is always more fun and better to have anyway than lower volts and more amps. So just briefly about my experience in all this, I've been building fast vehicles my whole life, fast e-stuff since about 2015, so coming up on 10 years of that, and building battery packs also for these fast e-vehicles since 2015. I did 14 battery packs for myself, for my own vehicles, before this Sur-Ron battery pack build, so have some experience doing it. This has definitely been the most difficult battery pack build that I've ever done. I say that with each one, but it's been true. Some parts of it were not hard at all, but in general, there was a lot of time and work in the researching and in the finding components part of it. The actual welding and putting the pack together and attaching the BMS wasn't really that bad. The main issue with it is it fits into a very, very, very small and tight space. There's zero extra space for it, so everything has to be done in a really condensed space. So first, let's talk about pros and cons. Why you would even think about building your own Sur-Ron pack, and why you would not want to build your own Sur-Ron pack. Why to do it and why not to do it. Well, on the why to do it list, first of all, the most obvious, I think, for most people is saving money. The kind of secret in the industry is that on all the sort of big brand name packs that you are looking at, I won't name names, but the larger brand names that people are familiar with, over half the cost of the pack is labor. The materials cost of that pack, obviously the main material cost are the cells, which everybody can research, but the materials are in generally a little bit less than half the cost of the finished pack. So if you can build it yourself, if you have the time and the desire and the ability, obviously to save half the cost on a $2,500 purchase, that's something that's desirable to a lot of people. So of course, saving money, I think, is a big, kind of the first thing that people think about. The second reason, which was important to me, is when you build it yourself, you know what cells are in there, you know the quality of the build that you're doing yourself, you know that the cells you're using are authentic. Hopefully you got them from a supplier who you can trust that they're authentic cells. You know the quality of the wiring that you're using in there, you know the quality of the connections and the bus bars you're using, and you can really be sure that the quality of the pack you're getting is excellent. And that was very important to me to know I had an absolute top quality pack, because I plan on keeping this for minimum 10 years, hopefully more than that, like 12 or 15 years. So that was important to me. You know the quality of what's in there. Otherwise, anywhere else you buy it from, you need to kind of do a tear down to see that everything was built correctly and that you're actually getting the cells that you paid for. And number three, main reason why to do it yourself, is the satisfaction of building something that's rather difficult and complicated yourself. There is definitely a sense of satisfaction of the battery pack and the bike build, of having researched, solved all these problems, of which there were many, building it and testing and having everything work and knowing that you built it yourself. Definitely a big feeling of accomplishment or satisfaction. So those are the main reasons, I think, why to do it. Now, why to not do it? Well, obviously, number one is safety. This is a potential bomb, especially with the power levels and the number of cells that we're looking at in the Sur-Ron pack. It's a very, very powerful, any lithium-ion battery pack can be dangerous, even a small one, but this is a very large, very powerful pack. My battery pack has 198 21700 cells. 72 volt pack will have 180 of those cells. So if something goes wrong, obviously you can have a big fire, big explosion. So safety is very, very important, and the main reason not to consider it. And as I said before, if you don't have any experience building lithium-ion packs, definitely please do not do the Sur-Ron pack as your first build. Get experience with a few of them first. Number two, why not to do it, was the difficulty in sourcing components. I was really surprised at how hard it turned out to be to find all the needed components. This Sur-Ron pack, as opposed to other e-bike packs that I built, the Sur-Ron pack necessitates specialized components in several areas. First and most important are the bus bars. You can't use, I thought I would just find regular, nickel strips that fit my offset layout. I would use those. No, that's not the case. You need to use solid, either nickel or copper for bus bars. I originally bought just a whole roll of nickel, of 0.2 nickel, and was going to have it custom laser cut. And then with more research, I found that actually the best option were these copper nickel bus bars. So those are specialized. The holders are specialized. The BMS, only one size will fit. Fitting in is a difficult thing. And the cases, I spent many hours and weeks researching and trying to find cases for this battery pack, which was a whole nother story. So actually sourcing the components are difficult, but there may be at least some help in sourcing cases and the bus bars. And in the links to the video, I am going to put links where you can purchase these items to help DIYers find these parts that are needed. That's number 2. Number 3, that after doing all this research, in the process of it, I ended up contacting practically every battery manufacturer in China that makes packs for the Sur-Ron. Pretty much every battery manufacturer I have communicated with, mainly for the reason of finding cases, because I found looking for cases is actually quite difficult. Cases that are the right size and the right quality. And what I found out through all this research was that if you shop around and shop carefully, you can find from manufacturers in China 72-volt Sur-Ron packs, purportedly using high-quality cells like Molicel PP42As and Samsung 40Ts, for only about $300 over the parts cost that I'm going to go over here. So in other words, whereas kind of in the past, the normal quote-unquote labor cost for building one of these packs has been, let's say, $1,000 to $1,200 or $1,400, some of these manufacturers are selling packs for only about $300 over the calculated parts cost. Now, maybe they're getting the cells a little cheaper because of huge volume discounts, something like that. But anyway, if they're making the packs correctly with good quality, and if they're using actual quality cells, which I'm going to go over cells during this video, then to do all this work and all the stress that I had and problems, I would definitely pay a manufacturer $300 to do the labor, because the work and the time and the stress was not worth a $300 savings. But again, that's if I haven't purchased packs from these Chinese manufacturers, and I'll go over which ones later that I'm talking about. So I can't say for sure that they're using genuine cells, that what they advertise, and that they're assembled correctly with the right bus bars and the right holders and the right wiring. So I can't say that for sure they're doing high quality, but if they are, and if it's true, the real authentic cells, for only $300 over parts cost, to me it's a no-brainer. I would not build one again. I would just buy from one of those manufacturers. Okay, and number 4, why not to do it? Long and difficult process. This whole process took me many weeks of researching at the beginning, of finding the right type of parts, the right materials, the right pack layout. Looking for cases took many days. So by publishing this video and providing some of the resources to people who are interested in it, that will save you a lot of time. But still, in general, it has to be done very slowly. The assembly and building must be done very slowly and methodically, and it's a long process. And even if you source all the parts very quickly, you're still going to spend at least a few weeks, I think, working on and building the pack doing yourself. So the question is that then really worth it in order to save between $300 to $1,200 on the cost of the pack? That to me is debatable if it's worth it. But again, you have the satisfaction of building it yourself and of knowing that the components are good. So that's the pros and cons. And also, if you see from this previous pack, I used the regular nickel strips, not individual pieces of nickel, but the already made like 3 across, 2 wide, 2 high, or 2 high, 2 across, 3 high sets of nickel strips for welding. So those 2 things are out the window for the Sur-Ron pack, because you don't have space to use this kind of cell holders. You either need to glue, first of all, the cells have to be installed in an offset layout, which I'll go over in a minute, in order to have space and fit them, either glued together or with cell holders that have them offset, but you're economizing much more on the space than using this previous kind of cell holder. That's the first thing. The second thing is on your nickel strips, because the power level and the amps are so high in this pack, so much more than, for example, the e-bike pack that I made for the Canyon build. Nickel strips really just will not do it to hold that amount of amps. You need to use solid either piece of nickel, slab of nickel, or copper, ideally copper nickel bus bars like I'm using here. So, and that was a whole story going through that process. This was about a 4 or 5 month process from first thinking seriously about doing it to actually getting the pack done. And I just want to mention briefly, I have been known about the Surron. I built my first Surron from the ground up. That's going to be a separate video that I'll publish here soon. Built my first Surron from the ground up over this winter, but I've been around fast e-bikes and actually was hanging out with the guys from Luna Cycle back in 2016-17 when the Surron was first introduced and when they first started importing them. So in the beginning here, I'm going to go through chronologically, really quickly, photos of this whole process from start to finish, and just everything I've had to go through to kind of figure it out. So I will do that as quickly as possible with this voiceover, and then after the photos, go through briefly. I'm going to show you about a 60-second video that's basically how to build a pack in 60 seconds. If you slow it down to about 1/10 the speed, you may be able to follow along. It was from one battery manufacturer I found on Alibaba, so I hope they don't mind me sharing that video. And then I'm going to play clips from the actual assembly process that I went through of doing the pack. So, okay, now briefly, I'm going to do a cost example showing how much you might be able to save by building a 72 volt pack yourself. The cells I'm using in this example are kind of the workhorse cell of the industry for Surron packs. They are known to be great quality. They handle high output fantastically without overheating, and they're reliable and just in general a great workhorse cell, and that is the Molicel P42As. There's only two places that I recommend getting cells from, and I'll put screenshots of it here that you can know 100% that the cells you're getting are authentic, that they're reputable sellers. In Europe, that's Encon.nl, Encon Netherlands, and in US, it's IMR Batteries. I'm sure there's other reputable sellers out there. I know that there's some sellers where you can buy cells directly from China, but those two I know are reputable, and I know they're not selling any fake cells. So, but anyway, let's look at let's say you can get the Molicel P42A for about $4 each. For a 72 volt pack, you need 180 cells. So 180 at $4 each, that's $720 for cells. That's your main cost, obviously. Then the next absolutely key component you need for the build are the correct bus bars, the copper nickel bus bars, and you need the correct size and layout shape cell holders. Now, this can vary. In general, these have to be purchased from a manufacturer in huge quantities, and most DIYers aren't looking to buy 20 or 50 units of these. But like I said, I will put some links in the description below. I don't want to go over everything in the voiceover here about where to buy and how to buy, but let's just figure now for copper nickel bus bars and the cell holders, $180 cost for the pack. Maybe it'll be a bit less, maybe it'll be more, but I think that's a good estimate. So you've got 180 for your copper nickel bus bars and your holders. BMS, the BMS I use, and in general the largest that will fit on the top, which I'll explain later why that has to go there, is the Ant BMS 325 amp maximum, 130 amp continuous. Yes, higher continuous and maximum would be better, and I tried doing that, but I'll explain later why it didn't work. About $70 for the BMS, for 325 amp peak BMS. And about case, again, like I said, I've spent many weeks searching for cases, finding cases, ordering cases from manufacturers. Figure $200 for a case. It might be more, it might be $250 or $300, it might be a bit less, but about $200. So tallying all those up, you're at, and that's not including solder, that's not including your 6AWG wire that you need to use in your QS8 connector. It's not including Captain tape or the Fiberglass FRP sheets that you use for insulation. So you have some miscellaneous materials too, but not including those. I come up with a total of $1,170, and to buy from a reputable manufacturer, let's say like Chai Battery in US, an equivalent, and by the way, this pack would be easily capable of 325 amps output, limited by the BMS. So to buy an equivalent 72 volt pack like that, I think is going to be over double that price of $1,170, probably like $2,400-$2,500. So that's an example of the cost. Okay, so now I'm going to go through quickly as possible, chronologically, the photos of the build process and everything I've gone through to get to this spot. And then I'll show the quick 60-second build video and then clips of my build. So as I mentioned, all the packs I built in the past have been with these rectangular cell holders and with kind of the standard nickel strips. Here's some photos of the most recent pack I built for the Canyon Nerve bike CYCX1, which I made a video about. When I started researching building the Surron pack, which actually I started looking at this maybe 2 years ago, even before buying or building a Surron, I was most interested in how to build a pack and if I would be able to. So in doing that, I wasn't able to find a lot of information. There were a couple videos online about Surron pack builds, but they were woefully lacking in information and the real information that's needed to be able to build a pack correctly. So here's some photos of packs that I had found built before. In general, what you've got, I need to explain briefly about the difference between using 18650s and 21700s. As all these photos show, basically all the Surron packs are built as 2 bricks, which are connected together, the two, to make a 16 in series for 60 volt or 20 series, or in my case 22 series pack. They're connected together at the middle, because if you were to make just one long brick of a 20 series or 22S pack, it'll be way too long to fit in the case. So basically what you're taking is a 22S sort of block and folding that in half and connecting those 2 halves together at the bottom. If you see in this one picture of the pack that Bruno built, those 3 red wires at the bottom, those are the 2 blocks being connected together in series to give you let's use 72 volt for most of this discussion. So that's how it works. Now I need to explain a bit about the Surron build and geometry about 18650s versus 2170s, because a lot of people sort of ask why use 2170s, or why are the Surron packs 18650s? Does 2170 even fit, and all that? So super briefly, the Surron was developed between 2014 and 2017, which ironically was about the time that I started really doing fast e-bike builds and battery pack builds. At that time, even into 2017, the only cells on the market were 18650s. 2170s had just barely been introduced, and we're definitely not coming on the market in quantity. So the Surron frame was brilliantly and intelligently designed and built so everything fits to the millimeter with absolutely no wasted space. The Surron in general is a marvel of engineering design, and besides being functional, it's beautiful, and there's no wasted space at all. The guys that designed it did an absolutely fantastic job. So anyway, when they designed it, 18650s were the only cell on the market. They designed the battery pack size and the opening to exactly fit those 2 bricks of 18650s. And the way that they are organized in the frame is that if you look at, I'll try to show this pack here with the purple cells. The way you're looking at that, and by the way, this with the purple cells, this is an original style 18650 pack, but the way that this sits in the frame, the longer dimension you see on the bottom there, going kind of left up to right top, that longer dimension, that is front to back in the bike. The shorter dimension, where the cell ends are, the positive and negative terminals, that shorter dimension, that is left and right side on the bike. So 18650 packs, they fit in the Surron this way, no problem. That's what they were designed for. However, if you try to fit 21700s in the Surron, the same orientation, they will not fit. The cells are too long and they won't fit sideways like this in the Surron pack. So the way that we have to build a 21700 pack for the Surron is you take these 2 bricks and you flip them 90 degrees sideways. So now that the cells, the plus and the minus, the ends of the cells, are aiming front and back in the bike. That is the long direction now, is the cells are aiming front and back in the bike. And here where we're seeing the plates, the bus bars, that is on the sides now. So anyway, in order to fit the 2170s, you have to actually take that brick, you have to take the cell brick and flip it sideways. By doing that, you can fit 2170s in lengthwise. The minus of that is because you don't have much room left to right, side to side, you can only fit in about 9 cells. Some people I think have fit 10 with gluing them together, but I'm talking about with cell holders, you can only fit about 9 cell parallel groups in there. So the number of parallel cells you can have is much less, and therefore, in order to get the amps that you need for a Surron pack, that's high powered pack is going to pull 200 amps, 250, 300 amps or more, you only have, for example, 9 cells in parallel. You need cells that can handle very, very high amp output, and there's only a few of them. And I'll go over those. But a lot of cells, most of the cells on the market cannot handle high amps pulling out of them because we don't have many groups in parallel here, only 9. You can see on the this old 18650 pack, there was space there to have tons of cells in parallel, like 12, 16 cells in parallel. So if you have a 10 amp cell or a 5 amp cell, maybe not 5, it's no big deal. Anyway, so your cells, because you only have 9 in parallel, you have to have super powerful cells. So that was researching about the design of the pack. Now the other question comes up, well, why use 2170s? Why not just still use 18650s? Well, even in just the last 5 to 6 years, battery technology has improved immensely. I will use my absolute loved favorite cell from before, which I made all my packs with, which was the Samsung 25R, compared to its current replacement, high-powered 2170 cell, which is the 40T, which I've used for this Sur-Ron pack and my previous pack with the CYC. The 25R capacity and power output has almost been doubled in the 40T. It's not quite double, but it has almost double the capacity and almost double the maximum amp output in a cell that's just barely bigger, only 5 millimeters longer and only a few millimeters wider. So in a cell that's barely bigger, you have almost double the power output. So in general, the technology is much better, much more advanced on 21700s, and much better to use than to try to just make a new pack fitting 18650s in there. So that's why I went with 2170s, and that's why I think pretty much everyone building Sur-Ron packs aftermarket is using 21700s, even though the frame is not designed for it. In order to squeeze them in, you have to take and turn the battery pack sideways compared to how the original battery packs were made. So, sorry if that was a long background, but if you're interested in pack design, I think it's important to know why these cells were used originally, why 2170s are being used now, and kind of the technical info behind it. So the other issue that I ran into was just knowing how to do the cell layout. I saw these 2 bricks, 2 brick packs, but I didn't know if using my standard cell holders they were going to fit. Didn't know how the actual physical cell layout was going to be done. Through tons of research, found some photos and videos of people that had done 2170 packs for Sur-Rons, found some pictures of cell layouts, and in doing all this research, I finally came across a little video clip from a manufacturer that really helped me out, and I'm going to show it after these photos. The whole clip, it's I think a little over a minute. Anyway, this was really helpful because in here, this guy building this pack, it shows first of all the cell layout, which is an ingenious design, which is a 9P. He's building a 20S 72 volt 9 parallel pack. His is glued together. I don't recommend that. I'll explain why in a second. But it shows how he has the cells laid out, which I immediately understood and said that's a brilliant design. And it shows how he is welding it using these special copper nickel bus bars, which I had absolutely no idea how to find, how to spec, what size, how they would be, how to manufacture them. I thought I would just buy nickel plates and have them laser cut. Anyway, so this video I'll show in its entirety in a sec, but this really helped because I saw how he made them, how the pack was laid out, how the copper nickel bus bars are used, and in general saw and how he connected the 2 blocks together, and in general from this kind of realized, okay, it is possible to do it. A brief thing about glued versus cell holders, why I am not a fan of glued whatsoever, and I highly recommend do not make your packs with cells glued together. Why? Well, there's argument about whether the spacers giving a little air between actually allows better airflow, the pack to cool better. Some people believe that having the space between the cells by using holders does let the cells cool better because there's some air circulation in there. Some people don't believe it helps at all. Regardless of that, I think it does help marginally. Regardless of that, the main issue is with a pack which is glued together. Okay, you're building this pack, investing a lot of money into it and time and work, hoping that it's going to last at least 10 years, maybe 12 or 15 years. The issue with a glued together pack is if in the future one cell from one group goes bad, which can happen even with quality cells like Samsung or Molicel, if you have one cell go bad, you're going to start to notice what's going to happen. The pack is going to start shutting down. Instead of at, say, for example, 60 volts is your normal low voltage cutoff, you're going to be down to 64 volts, which is like 18% of your pack, and all of a sudden the BMS shuts it down. What's the reason? You go in and look at the diagnostic on the BMS and see one group is low, you try to balance and it's not working. That's kind of the nightmare scenario, but it can happen even with good cells. And what that means is either one of the welds has come off on your connections, one cell has come loose, or more likely one of the cells has gone bad. In all the packs I've done, I did have one pack with one cell that went bad. in a couple of years after making it. So it can happen. If you have a glued together pack, guess what? That whole pack is garbage. It's a brick. You can't separate or replace any cells. You can just go to the recycling station, recycle it, and start over. If you have cell holders, you can replace that cell. It's not easy, it's not fun, it's not fast, but it is possible to do. You can carefully Dremel tool and cut your bus bars. You can open up the pack. You can remove the bad cell from there, put it back in, weld in a new piece of nickel or copper bus bar, and you can replace the cell in a pack that is using cell holders. It's like I said, it's not easy, but it can be done. With glued together, you can't. So that's why the main reason why I recommend using cell holders. The main argument to not use them is for space. If you're building for a case where you absolutely cannot fit, for example, if this 20, the pack the guy's making here, this 20S9P pack, if this would not fit in a Sur-Ron any other way except to glue together, which actually is what I thought when I first saw this, then you have to decide, okay, maybe it's worth it to make a glue together pack and hope for the best that no cell is going to go bad if it's the only way it's going to fit. But I found, and I'll show in this video, it's absolutely no problem. The cell holders I have and that I found, you can fit a large pack in the Sur-Ron, no problem, and you even have a little space to spare. Not much, but a few millimeters. So no reason, in my opinion, to glue together the pack. I think it's a dumb way to do it. Okay, so we went through the Chinese guy building the pack video and how that kind of made it apparent that it actually was possible to do. After that, again, I'm just going to go through this as briefly as possible. I know it's long. Again, I say this in all my videos, but a lot of information. This is a many months long process. I'm trying to distill down into like an hour. The next step in the process was trying to find cases. I didn't even really worry about those bus bars. I thought it'd be kind of easy to find nickel or copper in the size I needed. As it turned out, that was not easy at all. I started looking at cases. First one I looked at was on AliExpress. I think there's a photo of it here, photos of it here. That was kind of the easiest place to buy it, kind of expensive, 250 bucks, I think. But the problem with the AliExpress, it was too short, too small. I calculated that I needed about a 400 millimeter high box for my 80 volt pack. I'm American, but I use, in this case, it's much better to use millimeters, much easier to say that rather than 17/64 or something. Anyway, AliExpress, the box was too short. I started looking, kind of contacted everybody who made packs to see if they would sell cases just by themselves. Started, as I said, contacting pretty much every battery pack manufacturer and in China, and about 90% of them told me to screw off, that they don't sell, cases alone, only finished battery packs. Spent many months, and here's just some different cases that I was looking at, different dimensions, different builds. Many weeks looking. Finally found a manufacturer who I contacted, who was willing to make cases for me to my spec, or actually to their spec, but it fit my dimensions that I needed. Anyway, very long story short, I ordered these to this dimension spec packs. The dimensions on the pack, as I'm saying from memory, they're 161 long, front to back on the bike, 138 wide, 161.5 long, 138 wide, and 400 high for the case part, and 420 in that center display part that goes up. I'll show a photo of it here. Those dimensions, this manufacturer, they assured me that those are fine. They fit in the Sur-Ron frame. They have clients that use them. However, in discussions with other battery builders, I was warned that these were going to be too large, that with those dimensions, which I just mentioned, with squared corners, those were not going to fit in the frame unless you wanted to do some grinding. And I contacted the manufacturer back. They assured me that they should fit, okay, that's correct dimensions. So went ahead and got these, had them shipped over from China, tested on my build that I was doing, and they don't fit in the frame. So was very disappointed. Took a lot of time and was kind of wasted on that. I contacted the manufacturer back, and they, from my input, they have redesigned the boxes, and they've done them with diagonal corners that are cut about 5 millimeters off the diagonal. I'm waiting for those to arrive, and hopefully they will fit. But in the meantime, this process started a few months ago. In the meantime, my pack actually has ended up taller than I originally planned, because I had originally hoped and planned to put the BMS on the side and found out that actually there's not room for that. And so the BMS, I ended up having to go with a smaller BMS than I originally wanted to and put that on the top. So because of that, these cases that I'm getting with a 400 millimeter high box, I'm actually not even going to be able to use for my build with this 80 volt battery. With a 72 volt pack, they should fit okay. So I actually went ahead and designed and had built 3D printed cases, which I'll talk about later. There's pros and cons to them, but I needed an exact shape and an exact size for my pack. Okay, going forward, Next thing I located was the cell holders with the correct layout and size for this offset configuration. I got a PDF of the sort of scale and the size of these cell holders in a large batch, and I will put a link to that. I'm going to provide some files like that and the STL files for the case for free if you want to. So I printed out the cell holders and made the layout of my pack, and also kind of here you can see from the photos, this was super helpful to sort of, I made a model of it and designed it sort of on paper before actually doing it in real life. So laid out how the pack was going to go, saw what the size is going to be, saw how the cells are going to go together, and from that sort of figured out my connections, my bus bars, how they had to be laid out, what size they needed to be, quantity, and how they were going to be made. So having these cell holders and having this PDF that you could print out and make the layout of the cells, that was super helpful. So there's some photos of it. I am using Samsung 40T for this build. They are excellent, fantastic cells. I absolutely love them. I love Samsung brand cells in general, although the 50S is terrible, which I'll talk about later for Sur-Ron packs. I got these from Encon, Netherlands. Samsung 40Ts I got for this pack. I was very torn between that and Molicel P42A. I actually was going to get the P42As for this pack, even though I love the 40Ts, simply because with Encon, my supplier in Europe, they were actually about €1 cheaper per cell, which is significant. The Molicel P45As are, I'm sorry, P45Bs are the current state of the art for high output cells. They're the best. They're the Rolls Royce of cells. They're expensive, but they're about the only cell that combines high capacity with high power output and don't overheat. They're definitely the best. Molicel is going to have a P50B later this year, supposedly coming out, that is going to be even better. But do not think that other high capacity cells are going to be a substitute that you can use, because I understand everyone wants to have more range, more amp hours, and so you see a cell that has 5,000 milliamp capacity, like the Samsung 50S is the perfect example of this. And you think, oh, I can substitute that, it'll handle 25 amps, it'll be great. No, not at all. Most high capacity cells do not handle high output, and the only cells that have high capacity and high output are the P45B and the P50B. So my 40Ts are pretty low capacity. They're only 4,000 milliamps, and my pack is only 36 amp hours because of that. But for me, much more important to have high power output, number one, and number two, low temperature and reliability. So that's why I use a 40T. It's not the latest and greatest, but they're still an absolutely excellent cell, and definitely do not use the 50S or any other cell that's not doesn't stay cool and isn't made for high output. Okay, sorry about that, again, it was long. Next, quickly, photos of the copper nickel bus bar. So I contacted many manufacturers, spent many weeks researching, finally found a source. I designed in CAD the exact size and the distance they needed to be, because remember, these have to match your cell holders, your spacing. Your cell holders determine the spacing between the cells and how large your bus bars have to be. So from those dimensions, after I found the spacers, I contacted a bunch of manufacturers, had custom sized and designed copper nickel bus bars made that match these cell holders. I'm considering selling these two things together as a package to make it easier for people. I still haven't decided as of this video if I'm going to do that or not, but regardless, I'll still put in the description links to where you can get these. So these are excellent. They worked fantastic for the build for this pack. I loved working with them. It was the first time doing it, and they made the welding process actually pretty easy after you laid them out. Just have to do it very carefully. It's like playing Operation with real life consequences. You have to be very careful when you lay them on there. But they're great, and we're definitely the pretty much key component if you're thinking about making your own Sur-Ron pack. Do not use regular nickel strips, nickel pieces, nickel sheets. I guess a solid sheet of nickel would be okay, but these still are better than that because, well, A, copper and it's thick, but B, the nickel part is not recessed, but extended down. So the copper is nowhere near the cells. The only part that touches the cells is the little nickel section in the middle. If you use a sheet of nickel, you're welding it and kind of tacking that down, pushing it right onto the cell on the positive side of the cell, which is not good because you're pushing the bus bar directly onto the cell, and the casing, the outside of the cell, if somehow it goes through the insulation, that is negative, is the casing, so not a good idea. So these are absolutely crucial. Into the spacers, laying them out in the spacers, used my diagram that I had printed out with the cell layout as the model for it, made that super easy, packed them in there, got them nice and even and laid out. The manufacturer of my bus bars. Also did a printout of how the bus bars are laid out on there, which was super helpful, and I even added to that and made a color diagram of positive and negative and how everything connected together. So again, like I said, I made kind of a model in advance, drew out a model of how everything was going to connect together. So here's photos just of the beginning of the process before starting to weld. One thing I'll mention here that I talk about later in the video too is I recommend really where your B- and your B+ are. Well, B- is a little difficult because it's connected to the BMS, but at least with B+, I recommend soldering on your B+ fat wire before welding your B+ bus bar onto there. That way you're not putting all that heat into the cells. So very important thing to do. Try to weld, if you have to solder any thick wires, try to do that onto your bus bars before you weld them on. So kind of did a test layout, put the bus bars on there. Next photos showing cell insulators. So real quickly, about cell insulators. In general, if you're not using cell spacers, holders like I have, it's an absolute essential must to use these green paper cell insulators. However, if you're using spacers, and especially with the copper nickel bus bars, they are not an essential thing to do. I was not sure about this at all. I saw some people use them, but a lot of people didn't use them with the cell spacers and the bus bars. So I actually contacted 2 different manufacturers of the copper nickel bus bars, showed them what I'm doing, said, look, are these necessary? Do you have to use them? And both said no. With the spacers and with these bus bars, they are absolutely not necessary to have. However, for an extra bit of caution and safety, I decided to go ahead and use them because the connection point on the bus bars is a little square that goes onto the positive part of the battery. So that square actually extends a little bit beyond the size of that center section of the battery, and just for extra bit of insurance that it couldn't touch anything, I decided to actually use 18650 cell insulating paper rather than 21700, because 21700 papers still leave a bit of a gap around that center positive terminal. I wanted to close that gap completely where the where the cell bus bars were going to be welded onto. So I used 18650 papers, and those kind of tightly, as you can see in the photos, completely wrapped around the positive terminal. That way there's absolutely no chance of anything from the bus bars touching anything other than the positive terminal of the battery. So just for extra safety, I use those, but they're definitely not necessary. And I even found some photos and videos from these battery manufacturers using my same bus bars without insulating papers. So even the manufacturers don't use them, so you don't have to. Going through the welding process, starting to weld, these things make welding super easily. Obviously you need a good welder. I'll go over that later, what welder I got. You need one that's powerful enough, but you just have to put these on very carefully, make sure they're centered, and welding them really is a breeze. I did 6 welds per connection. So here's the blocks as they were being welded. After they're welded together, how the blocks look, very pretty, very professional looking. Really love using those bus bars. Just make it totally professional. Next step after that is doing the insulating paper, connecting the 2 bricks together, and the part that I was really, and testing obviously your voltage. You want to test your voltage at all your BMS connection points for every series. Make sure your voltages are correct at every one of those spots. Again, I'll go over this in the video. The thing that I was really worried about and kind of dreading was the connection of the 2 bricks, how he was going to do it, and soldering on there. I hate soldering fat wires, especially with battery packs, because you do not want to heat up the cells at all. So okay, about connecting the bricks, I looked at a bunch of different ways of connecting the 2 bricks. The bus bars are really intelligently designed, and they give you holes on these end pieces where if you had space, the ideal, by far the best way to do them together would just be to use bolts and nuts and bolt them together that way. Unfortunately, because of the height restriction, the size restriction with Sur-Ron pack, there's no space for using nuts and bolts. You have to pretty much use wire and solder them together. So continuing on, this is after the 2 bricks were connected. Next step is attaching, organizing the layout of carefully and attaching all your BMS wires, laying them out, attaching, cutting them, soldering them. As I mentioned, I originally, when I had done sort of the layout on paper, I thought I was going to have room on the side, on the shorter side of the pack, to fit the BMS on the side. And so I got a long, huge 525 amp, I believe, 75 peak BMS from Ant BMS, 270 continuous, thinking it would be on the side. It didn't fit on the side, as you saw, almost no extra space in there. So I had to, unfortunately, go with the BMS on top, which limited my BMS to a much smaller size one, only 325 amps maximum. So laid out the BMS wires, keeping in mind first marking the location of where the BMS was going to go, kind of attaching the connectors up there at the top where it was going to be, and then attaching all the BMS wires. So there's the process of that. Attach the BMS wires, connect everything together, insulating with Captain Tape, test fit of the BMS where it's going to go, putting the BMS in place. Then you need to cut your B minus. Well, you have to solder your B positive wire. As I mentioned, much better to do that in advance before you even do the welding of that plate onto the battery. Then laying out and cutting the B minus wires to length, you can see here, and laying them out. And again, everything, because of the space limitation of the Sur-Ron pack, everything must be really, really compacted, very compacted together, made in a very small space, and that was definitely the most difficult aspect of this pack build. Connecting the B minus, putting the BMS in place. B plus is under there, making sure everything is super insulated. Insulation on the bottom of the BMS, insulation where B plus is, where B minus is, because you definitely don't want that bottom of the BMS is conductive, and unfortunately it's right next to, basically it's like a wire going between B plus and B minus. They're right underneath it, so had to do a lot of insulation there. Did my fiberglass sheets, protection sheets, those FR4 I believe they're called, fiberglass sheets on there, cut them to size, glued on. You can see here testing how everything fits inside the 3D printed case. I will still get a metal case. If I can get a case fabricated to the right size for this, I'll use a metal one, but I talk about more in the clips about this 3D printed, the pros and cons of it. I'm actually pretty satisfied with it, and I think it's going to last just fine. It's 2.5 millimeters thick. PETG material. So test fitting it in the case, had to make 3 different versions of the lid for the case because the pack ended up actually being a little taller than I was hoping at first. So the first couple versions were flat, and then I had to make a version that sort of had a bump up in the middle, like a hood scoop on an old Dodge Hemi, to fit the BMS, and that's my finished shape, is with that bump in the middle. But everything fits okay in the bike. You can see here the photo. So this is what the final case looks like, what it looks like on the bike. Now I will, and again, thank you for tolerating this very long description. I tried to, again, go as quickly as possible, but this is distilling, like I said, months and months of work and research and time trying to get it down to like 1 hour. So that was the process of going through and doing it.
First, select a battery with the same voltage, capacity, and internal resistance, and assemble a bracket for the battery pack. Second, paste high-end battery paper on the positive electrode of the battery and fix the cylindrical battery on the bracket. Third, use electric welding technology to realize the connecting of batteries, BMS, wires, and other accessories. Fourth, paste a large area of high-length battery paper for the battery pack to achieve in solution. Fifth, test again whether the voltage and internal resistance of the battery pack are up to the standard before wrapping the battery pack.
I originally planned on just doing a 72 because that's, what everybody does for the upgrade. However, when I was researching BMSs, I decided on the ANT BMS with Bluetooth. That's kind of what all the high power Sur-Ron builds use, is the ANT. I'll put info about it here on the screen. So was reading and researching and deciding which ANT BMS to buy. By the way, I ended up with I think it's 170 continuous 400 peak BMS, kind of their biggest one. I noticed that they had both 20S and up to 22S BMSs, and I thought, that's kind of interesting. You can do an 80 volt pack, nominal, 80 volt pack, nominal, but when it's fully charged, it's 92.4 volts. So that's quite a bit more voltage than a standard standard upgrade 72 volt pack. Anyway, long story short, then I was calculating the size, looking at my case size that I found, and realized that there is going to be space actually for this extra series on both bricks to fit there to do 80 volt. And I am a big fan of higher volts. I always prefer to use higher voltage rather than higher amps for many reasons, heat and a lot of other reasons. If you see my earlier videos doing the 72 volt BBS HD, it makes a huge improvement, huge difference going from 48 to 52 to 72 on the BBS HD, and just in general, more voltage is always preferable. So since there was space, and since ANT BMS made a 22S BMS, and I thought, well, why not? I've got room. It's barely any additional cost, and I can can have 92.4 volts fully charged, and plus it adds a little bit of watt hours to my capacity. One little bit weakness of this with using the 40T or any high output cell, they don't have huge capacity. My Samsungs have 4,000 milliamp hours, so this is going to be a 36 amp hour 80 volt pack, but that's a whole other topic. But I highly recommend do not be lured and fooled by the high capacity, quote unquote, high power, quote unquote, battery cells like the Samsung 50S, like the LG M50LT that are 5,000 milliamp hours. Those are terrible, terrible, terrible cells to use for a high power pack like this. They're not meant for high amp draw. When you draw high amps from them, they overheat. It reduces their cycle life. Plus, I don't want cells in my battery pack, when I'm riding, cells between my legs that are 85 Celsius. I'm going to do a whole video and separate kind of article about why the 50S is a terrible choice. I see not a lot, but some battery manufacturers for Sur-Rons using 50S cells in their packs, and it's a terrible choice. It's like a 5 to 10 amp cell maximum. Once you start trying to pull 15, 20 amps from those, or even 25, they overheat, and it's dangerous, and they really reduce the cycle life too, and same with those LG M50s. Anyway, sorry, again, long story. So got the layout, realized that I could fit 22S in here. So again, if somebody is doing the same thing from scratch, there's very little additional cost and no reason not to, because your battery case is going to be, the inside space of the battery case, this is 360, so the case is going to be like to here. You've got inside space like to there. So why just have this be air? If you can add, for 40 euros more, add another row of cells and have more voltage and add 10% of the capacity of the battery to the watt hours. This, by the way, when it's finished, this pack is going to be 2,880 watt hours. So not the biggest, but power, again, more important to me than capacity. And still, it's like 50% more than the stock Sur-Ron battery. Again, I know this is long, try to make it as short as possible. So once I had this layout, once I knew my cell layout, once I knew it would fit, and I knew that, theoretically doing this build like this was possible, I was not nervous about doing the pack at all anymore. I was really very apprehensive about building a Sur-Ron pack because I didn't know how I was going to do it, didn't know the layout, even though I built a lot of packs, this is complicated, this is a tough one. So once I sort of understood this and knew it could be done, I feel totally confident about doing this pack. So, is 1,000 to 1,100 parts cost, is 2,300 a fair price to pay for a pack? It's hard to say. I would say that that originally, when 72s first started coming on the market for Sur-Rons, and they were very hard to come by, and they were sort of, enthusiasts like me and boutique shops doing them carefully by hand, I would say that that 2,300 with 1,000 parts cost was a fair price for that labor and for an expert doing it. Now that the Sur-Rons have been around for a while and there's more people doing it, more competition, to be honest, I think it's a little too expensive for the amount of labor that goes into it. And if you know how to build packs, or you have some experience with it, by the way, if you've never built a battery pack, I really wouldn't tackle Sur-Ron as your first pack. I would do a very simple, like a scooter-shaped rectangular pack, just 10 across, 5 wide. So with a parts cost of about $1,000, is $1,300 labor on top of that fair? I think it was several years ago. Now, to be honest, I think it's kind of high, and I think I do want to get one of these manufacturers' packs, buy it, and kind of tear it apart, tear it down a little bit, open it up and check it out, and see if the build quality is really good, and see if they're using real cells. Maybe that's your discount, is they're saying they're P42As, and in fact you're getting Chinese Lishan or EVE, crap cells. So that's a possibility too. I'm building myself because I know the quality is going to be good, and I know the cells that are going in there. Okay, two last, quickly, aspects about the pack that are important to talk about. That is your bus plates, and I'll explain in a sec, equivalent nickel strips on normal packs, and the battery case itself. Talking about these things, what are these? These are my models that I made for the bus plates, I noticed that on the, and I've never used these before, but when I was looking at people who made high-powered Sur-Ron packs, normally you use nickel strips, but I noticed when looking at Sur-Ron packs that some others have made, they use not strips but solid pieces of nickel, like one sheet of nickel cut to the right shape with little X's cut in the middle for your welding. Solid pieces of nickel, and obviously it's clear why that is, because when you have such high amps and such high power going, you want as much meat, as wide as possible nickel going between these series groups, as much nickel as possible. So with a nickel solid plate, obviously instead of having little 6mm or 5mm wide strips going there, you've got the whole plate. So much more width means more amp carrying capability. So it totally makes sense to me. I ordered my cells, thought, it's going to be no problem. I'm going to find somebody who makes nickel strips or, pieces the size that I want, no problem. A few weeks ago, I started looking for those and found actually it is a big problem. Long story short, couldn't find anybody who made the nickel plates in the shape that I needed. I ended up ordering a 1 kilogram roll of 0.2 nickel, an actual roll of nickel, 100 millimeters wide by, I forgot, it's not like 20 meters long, I think. And my plan was to get this roll of nickel, get the shape done on CAD, do the shapes that I needed, and then take it to a laser cutting place here in Ukraine and laser cut the plates that I needed. That was my original plan. I realized that actually for super high current, copper is better, handles high amps better than nickel. The really high end, and this is again another sort of trade secret that I'm giving away just because I want to help the community, other people who are thinking about doing this, other trade secret like this layout, is that the high-end manufacturers, if they're doing it right, the way that they're connecting the groups, the series, is with copper. I'll call them bus plates. I don't know the right way to say bus. A bus bar is a piece that goes across at the end. Copper bus plates, but they're copper nickel. They're copper with a nickel insert in the middle, little square nickel where each cell is, with the little cross cut out that allows you to do the welding properly. So they're copper nickel bus plates. So long story short, the manufacturers who are doing the high-end packs, by the way, some of the brands that you know and have heard about are actually manufactured by these same manufacturers in China. No, I'm not going to say names or whatever, but just keep that in mind, that years ago, even when I started doing this in 2015, the phrase Chinese cell or Chinese battery, Chinese quote-unquote, I'm doing air quotes, Chinese battery pack, like those original Hailong e-bike packs, that was synonymous with cheap, catches fire, bad quality, total crap. Well, guess what? Now, 8-9 years later, it's not the case. Chinese built pack doesn't mean low quality, and Chinese cell doesn't necessarily mean low quality either, despite what I just said a moment ago. The highest level of performance to do this is with these copper nickel bus bars, bus tip plates. So since nobody makes, you can't just go on Amazon and buy those, I end up working with a manufacturer, doing the layout, doing the design based on my cell layout here, based on my holders that I sort of proprietarily found. These are not just on Amazon or AliExpress. This is from a manufacturer that I found in Europe. And I'm having, for me, custom manufactured these copper bus plates. I will try and help you to get these parts if you need them. But to use regular nickel strips, obviously you could just use nickel strips and weld, going across. Well, these are separate, but going across here, you could use just nickel strips and weld them like normal, or they make nickel in a zigzaggy pattern, which I thought I was going to have to use. But let's be real. If you're pulling 200 amps, 250 amps, 12, 15, 20, in my case 25 kilowatts, you want as much material here as possible, because it's just the amount of power going through watts, it just translates to heat. If you don't have enough nickel connecting, there's enough material, or copper, it turns into heat, much like an old lighting filament. You're gonna light that up and just melt it like an old lamp filament. I contacted basically every battery manufacturer in China who's making battery packs for Sur-Rons. There's no such thing really as a battery case manufacturer. They're all battery manufacturers who also, some of them also make their own cases. Contacted every manufacturer in China. The short version is pretty much nobody wants to sell the case alone. Obviously they want to sell the entire battery pack with the case, which is understandable. Very few were willing to sell only cases. I found a few who were, though, out of like more than 20 manufacturers, and ended up choosing to go with one manufacturer. They've been great to work with, making the cases pretty much to my spec. I mean, they have a standard size, but sort of, had them built with in mind to have enough space for this 2170 pack layout. The cases that I'm getting are no, again, if you're sitting on the bike looking down, they are 140 wide by 161 long by 425 high. The size inside the box where the cells go is 400. Overall is 425, which requires, like I mentioned before, a little lift kit for your battery box. It doesn't fit with a stock battery box. I'm not going to be building battery packs for profit. This is just to do myself the way that I want to do it. So again, like the other videos, I keep saying sorry for the long video, but this is condensing literally hundreds of hours of research, work, communication, talking with other owners, Sur-Ron owners, other Sur-Ron modders, other battery builders, component manufacturers, researching about cells, even all this research, and obviously just the research about Sur-Ron, about controllers, about what brakes to use, what wheels to use. So this has been several months of research and learning and trying to just condense it down here. And so if you're going to do it yourself, one other thing that's arrived now, getting ready for the build, is the cell holders. These look really good put together. So all set for my 20S9P 21700. BMS is here also. So hopefully this coming week, get the cells and get started on battery assembly. My custom copper nickel inserts, bus plates, those are now in transit from the US, from China, then to US, then to here. So things are moving along. Just, of course, always it takes longer and costs more than you originally hoped for, but it's going to get there. First package, 50. Let's look at the date. I love how this thing doesn't focus, it's so nice. Date code NG2T. NG2T. Second package 130. So this is correct 180. Of course, Customs didn't deliver my second box yet. One that doesn't focus. So same date code and everything, NG2T. So very exciting part of the build has just arrived today. These are, I know for most people this is not exciting or interesting at all, but these for me are very exciting. These are my custom made copper nickel bus bars for the battery pack. Very cool. They look really awesome. We'll do some test fitting, test layout, but very cool. Excited about this. Here's a little better shot of them. I know for most people this is not exciting, but for me, super, super exciting. First time I've ever done custom made, custom design, solid copper, no, meaning not strips, solid bus bars made of copper with nickel inserts. Super excited about these. So actually, today is like Christmas. Two key components came in. My case that I'm actually going to use, and of course the RS. Case looks great. Really like the quality on it. Those wires are ridiculously thin, going to be changing those out, but well, in general, looks great. So running into a little bit of an issue. It's not fitting here. No, it's touching there, these holders in the back, and here in the front it's getting stopped by the welds. I'll try and show. Now I tried pushing it back a bit. I loosened the back plate here. It doesn't look like it will go in unless the welds are cut. Two options. The box needs to have rounded corners here on the front sides, or I would have to grind off part of these welds on the frame, which I absolutely do not want to do. So you can see right there where it's hitting on this side and on that side. I would have to grind off a huge chunk of this weld here and that weld there on the frame, which I am not doing. I'm not grinding off structural welds on my frame. If this was rounded with like a 4 or 5 millimeter radius, it should fit okay. So this is the internal space with my cell holders. There is actually space on the top and on the side a little bit, but remember, this is with no FRP, which is going to be there, no tape, no copper. But the issue is I was planning on having the BMS there. No way it's going to fit. I don't think without cell holders it's going to make that big a difference. And as we now know, can't go any longer this way because this box is already too big. There is room, I think, to round these corners. However, that doesn't help with the issue of the BMS. BMS is not going to fit. It's really weird because I thought I had calculated that I had plenty of space for the BMS, but really we don't. And if it's to go on top, it's going to be a much smaller BMS. So to say that this blows, that's an understatement. Well, here we go. Wish me luck. Important little step here. Gotta make sure they are, I know it seems silly, but they gotta be all perfectly seated in the holder and level, so when you're welding, everything is on the same exact level. So first block put together, these holders make it super easy. Going to do the second one and then check for voltage. Obviously you can do either way. Some people do all the voltage checking before putting in the holders. I'm not going to glue them or anything. I'm going to turn it sideways and then check the voltage that way. But obviously it's good also if you check the voltage before putting the holders. I just chose to do it this way. I've used so many Samsung cells, hundreds and hundreds and hundreds, never had a bad one, but of course still very important, check that the voltage is matching on everything before you do any welding. One thing, make sure that these are seated all the way down. I was looking closely and saw that some of them were not totally seated in there, so I'm kind of not doing this hard obviously, but just going over everywhere on both sides. You want to make sure that these are, totally down flush with the top of the cells. So blocks are done. Time to do a voltage test and then do a few dabs of hot glue to hold everything together. So that's it. Tested all of them. No, I can't do it and hold the phone at the same time, but tested all of them. Every single cell, all 198, measured exactly 3.44 volts. Not even a 100th volt variation. They were all 344, so great job. Samsung quality control is awesome like usual, and they're good to continue the build. There's our plates. I just got done making a little model So hopefully I don't blow anything up. No, I know it may seem silly, but just want to make sure that our connections are correct. It's going to kind of go like that. These are the two blocks. Here's the inside part, here's the outside part. Starting there, B minus, going down through 11. That's 11 negative. So on the back side of that is 11 positive, and then these two plates connect. 11 positive goes to 12 negative. Then comes back up along here, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22 to B plus. So if all goes well, it's going to go like that. One thing that's very cool with these bus bars, they even made them with the little tabs for the balance wires going on the right side. So these are like mirror image of each other, and even the end pieces are like mirror image. So they really thought it out and did a perfect design on these. Very cool. So basically starting off like that. This is going to be B minus. Putting the plates on here, no, I know, I just setting for now, but gonna weld. But when I set this on here, I felt like I was playing the old kids game of Operation. You don't want to short the wrong circuit. So, got an important thing today. Yep, it's my 3D printed case, and it fits perfectly. These dimensions are perfect. By the way, if you're building a case, let me tell you the perfect dimensions, at least for my frame. This way, 158.5. That original box is 161, doesn't fit. You could probably even get away with like 159. 160 I think would be pushing it. Width, 136. That's about the max. And this diagonal here, it's 6 millimeters, cut in from each side. 6 millimeter diagonal. That fits perfect. No movement, no play at all. No, you could probably get away with 159 on the length, but anyway. So, got a case that fits. Let's see, on the top. Not hard to tell that way. No, about 7 millimeters of space on the top. Side to side is definitely tighter, but there's a few millimeters on either side. Should be enough space for, all that's going to go there is the balance wires and a sheet of 1 millimeter fiberglass. Now, height wise, that's tons of space. Actually doesn't look like that much, but looks like actually about 23, 24 millimeters. I mean, it's tall, no question. It's definitely a tall case, but to have an 80 volt high power pack, I'm totally willing to live with that. Okay, here goes nothing. One main question I had is about the insulators on the positive terminal. I talked with both manufacturers of these plates, bus bars, and they both assured me that with cell holders, these are not necessary. These give you some clearance between the, where the terminal is on the copper. But to be safe, I'm going to use these paper just to give a little extra protection between where these rectangular pieces, they kind of overlap a little bit where the positives are. Just to give a little extra protection there. I'm doing one weld here to test to make sure, because this actually is about dead even with the top, the positive terminal. So just want to make sure we get good contact there. Gonna test weld one section, and assuming that goes okay, then hit all the positives with paper and start welding. And first welds on there. Nope, they seem to be holding on there really good. Hard to know exactly what power level to do. No, I tested on some, I can test on blank pieces of nickel, but for this, your first test is the actual welding on the cell, but I had a little too strong, I backed off a little, but these are holding good. Appear to be, hopefully they will. Need to make pieces to fill this empty space, to fill here. In general, will be shaped like that, but solid. And we'll go in like that, in here, to fill this space. Like that. In process. So far so good. Hopefully my welds are gonna hold. I'm doing 6 per cell. Laying these copper bus bars on the active pack is kind of like playing the game Operation, but with real life consequences. Thank goodness, so far it's been okay, but don't do this when you've had a couple beers. One block welded. 3/4 of the way done welding. Gonna rest for today, finish her up tomorrow. So, welding is done. Kinda double checked and triple checked everything. Seems like welds are strong and holding okay. Had to pause after each few minutes of welding because the wires get too hot. And my welder, this thing, it works great, but only has enough charge to do like one side of one block. So doing the whole welding took like a day and a half. But anyway, really glad to have these copper plates and excited. Here's our connectors. Connectors are there. Those two get hooked together, not right now. And then B plus and B minus are here at the top on the outside parts. So good, it's in progress. Keep working on it. Blocks have been married. They are stuck together and not going anywhere. Now the real moment of truth. I haven't tested this yet. Did a quick connection at our connection point. Okay, what do we got? 76 volts. No, I think that's a good sign. It's 80 volts nominal, and they ship the batteries at like 3.4. No, not 3.4. Anyway, less than 50%. So we're showing almost 76 volts. So that's a good sign. Okay, and this is how we're fitting in the case. Holy crap. That is close. No, I'm glad. Better to not have unneeded free space, but that is close. A few millimeters on the sides here, so I will be able to put a, strengthening piece here. On the top though, I gotta measure, but honestly it looks like only about 3 millimeters. Hopefully I have enough space to put the FRP sheets on both sides. But no, hey, that's not bad. No wasted space. Fits really, really closely. That's the fit with 2 FRP sheets. No, figuring one for top and one for bottom. There's the side pieces. Okay, concentrating so much, I didn't even think to film this. No, not fun part of the pack build, but it has to be done. Obviously, ideally, you would just bolt these together. It would be great. Don't have clearance though with the height of the battery pack, so has to be, connected horizontally. Started with a super heavy gauge wire. If anybody who's soldered, it's very, very hard to solder this thickness wire and this thickness copper. Almost impossible. Plus you're heating it up so much, you do not want to heat it, near the cells. Even though I put insulation behind, this still gets hot and gets to the cell, so kind of sucks. Like I said, would like to bolt. you could theoretically put bolt and screw nut in there and attach that to the wires. Kind of no clearance behind though. So I decided I'm going to go with smaller gauge wires. These are like 8 gauge, 10 gauge, but a bunch of them. And the easier way to do this, in case if you're doing the future, first make a solder pad. And actually you could do this while these parts are not even attached to the battery, which would be great because you're not heating it up then. So you put some flux on there, you heat up the copper with the soldering iron, heat it up, and then you make a pad of solder, do it on both sides, then put some flux on your wire, put it down, and then just press down the soldering iron and it'll attach, instead of trying to just heat it like crazy, you know, and without any solder on there. Much easier to just make a little solder pad first. So yeah, it's a lot of work. That's why it costs, you know, people charge $1,000, $1,200 for labor. Okay, that's it for subjecting my poor pack to all this heat. I think it'll hold 270 amps. I found kind of the best method, which is you first make a solder pad. So you heat up the one section of copper, put flux on there, heat it up, and then make a little pad of solder. Then I was able to use more of these thicker wires. I think these are 6 gauge, 8 gauge, anyway, by kind of flattening the ends. So cut to length, twisted them, and then with the pliers kind of flatten the ends to get them as flat as possible. Gives you more surface area. That way, just put them on there, put a little flux, heat, and put some solder on, and then it sticks to the solder pad. So hopefully, I think it's more than enough current. Hopefully, handling. Hopefully, I did not, you know, put too much heat in the cells. I think they're going to be okay.
Okay, checking our voltages. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, B plus.
So, just a quick break here in the midst of doing the BMS wiring. I tell you, $1,000, $1,200 for labor on these is really not a high price, because I spent the better part of yesterday doing that, and then yesterday evening started these. Today it's going to be the whole day till these are finished. After you do the attachments, you need to take and your multimeter hook to the B minus on one end, and then very carefully check the voltages on all these to make sure they're correct and they match your I tested the voltages at each BMS pin there, and you have to be very careful. It's like playing operation again, because you can't cross over, short those across each other. So it's coming. Just have to go very, very, very slowly. Take kind of normal working speed and divide that by 4. My QSC cable from AliExpress. I was kind of doubting if it was actual copper. No, it's tin copper. When I cut it before, it looked kind of like tin, but looking at it like that, I can't, unfortunately, focus closer. Looks like it is copper on the core. Hopefully that's it for BMS wiring. And just to show how much like operation this really is, you have to test each little terminal there without touching them across. If you do, it's a very, very unpleasant situation. And just carefully check each one, the voltage going across, that you're matching the voltages that you got here. Okay, so the voltage is all checked out. That's a good part. Next step, not really looking forward to, is going to be, first testing the BMS position. No, I can't put it there because it's metal, but BMS is going to go like that on top. Did a test fit in my case, and it does not fit even with a 410 high case. This block is 390. The BMS, by the way, this is Ant BMS I'm using. It's 16 millimeters thick. It's a 130 constant 325 max, which is really not enough for this pack, but it's all that will fit. The big one that I got, I planned on going on the side, and there's not enough space. Anyway, so with a 410 case, this doesn't fit after you allow for space for connecting B plus and B minus here. Not enough space, so have to make now a custom new cap that's going to be in this shape, new lid for the case that's going to give an extra 10 millimeters in the middle here, which should give enough space for BMS and everything else there. So yeah, a lot of customization. That's basically how it's going to sit on there. So battery stuff, I had these inserts custom made. They fit in there to fill empty space, mainly for the bottom here, so the battery is supported all the way across. So lightly glued those in, gonna put some insulation, close up the bottom, and start working on the sides. So going in like that, then everything gets glued and taped in place. Got it standing even and flat. Took 3 layers of fiberglass board. Finished bottom, hopefully. So after my big bummer of milk racing experience, back to positive things, which is working on this awesome battery pack. Got the side protection on, got the bottom, both sides. Gonna test fit in the case now and make sure I still have space widthwise. This is front and back widthwise to put the FRP sheets here on these sides too. I was thinking about doing my B plus and B minus soldering, all that stuff today. I'm emotionally drained because of the wheel experience, so I'll finish this and that's going to be a day. Okay, this is how it fits in there. Holy crap. There's literally like half a millimeter. Holy shit. But the good news is there is a little bit of space on the sides. Hopefully enough for both FRP sheets left and right. Gonna measure here and see how much space, but no, I calculated there's like exactly enough for the BMS without soldering these wires, so not enough space, but I'm extending the top by 10 millimeters in the middle, so now I should have plenty of space for the BMS and the charge port. It's going to go in there. So yeah, it's going to be a pretty tight fit, but it should be okay. Okay, mostly done. Well, I haven't taped it up yet. So why did I not extend these all the way out to the corners? Why are they a little short of the corners? Because the fit is so tight that, you know, with my angles it won't fit. So gonna tape it up everywhere, wrap around tape, and it should be good to go. That's how the BMS fits. So no, without obviously doing battery plus and battery minus, but should be okay with 10 millimeters extra space with the cap. Anyway, it fits. Should be actually plenty of space to fit wires under here and some insulation. How it fits with the new cover. Nope, pretty tight, but it fits. If I had to, I could do these a little longer, but it fits okay and tightly. That's how it looks from the side. Oh, I think it's cool. Problem is where the QS8 is going to go. Okay, about where the QS8 coming out of the battery has to go. I was planning on in back, but there's absolutely no space for it to come out the back there. It's got to be towards the front, and where we have lots of space. Okay, another thing that's part of this that is additional work if you're making your own battery pack and takes a lot of time. I already spent half a day on this, which is because this is so tight, I had to put the case in place, figure out exactly where my connectors are going to go, where I have clearance there, and also how I want this to be able to come off. If these are just going to come small holes straight through the cap, then you can never pull this off without resoldering. To be able to have it removable, you have to do a little hole at the edge, which sucks, but that's the only way it's removable. Then you have to figure how everything's going to be oriented, where there's space within the case, which is really tight, how the cable's going to go, where it has to be soldered on exactly, and then how it's going to run and where it's going to go, you know, underneath where there's space to have it fit. So yeah, a lot of work. So I cut this thing to length. Still don't like this kind of wire, this tin, super thin strands. It's like more tin than copper, but I already got it, kind of too late to change. And then I did the solder pad method on the copper bus bar, which will make it easier to attach these. So positive is done. That was as unpleasant as I was dreading. It's my most hated part of battery builds, is having to solder thick wires onto the battery because it heats it up and it's hard to solder. Hopefully my solder joints aren't all cold. They're okay. They'll hold, I hope. And on to the next step. More fun. I realized that there's only one way to wire the negative on the BMS so that it sits okay. So it's like that. They go under and across like that. So I've got these done like that. These were easier to solder than the B positive. So that's how it's looking. I just measured. I have 418 inside space. To the top of the BMS is 415. I have 3 millimeters. And I just realized I forgot to do my 12 gauge for the charger wire soldering here. Kind of stressful work, actually, this part of it. Very stressful. Glad most of it's done. 3 millimeters. Okay, I'm doing initial setup. Got the B- connected, tested all the balancing wires. They're all fine. Detected voltage are all fine. Check the this is a 22S and I have about 76 volts. I checked the voltage out of here and it's like 67, not 76. But now at first I didn't have. Now I have blue and green LEDs. About connecting a 3.5 volt battery to here, I measured across these first and two, and I'm getting plus 48 volts here. So I don't think I should be connecting a 3.5 volt lithium-ion battery here. So am I booted up okay? Is it okay to go when I do first charge? Should I see that voltage corrected? Because I have 76 volts going from B- to B+ now with this 22S, but coming out of the BMS here and here is showing 67. The thing about this particular pack that makes it so difficult and so time consuming is it's so tight. It's so tight for space with a 22S 80 volt pack that everything is just totally packed in there. I mean, to the millimeter. With how this is right now, I'm at 415 millimeters high and I have 418 space inside with the new cap. So I have 3 millimeters. And, you know, on every other side, no space. So it's just very, very tight, very shoved in there. Makes it much harder and much slower to build a pack. My high-tech workshop, rental apartment. Well, that's it. Not fun. I know it doesn't look pretty, but we'll get these all wrapped. Main thing is they're secure. They're going to be insulated. Everything's going to be protected from each other, and it fits. Extremely, extremely hard working in super small space and have to organize everything so it fits in here. This pack is really like 3 times as hard as normal because trying to shove everything into a tiny space, but I think I got it organized so it'll fit. And that, amazingly, is how it will fit in there. No, it's actually cleaned up better than I expected, but hopefully everything fits okay. Gonna do a little more insulation, a couple dabs of hot glue so nothing moves. Main thing, no red touches, no black. Okay, that's it pretty much. A couple dabs of hot glue. I did like triple protection anywhere where something might touch something. Did like 4 layers, wrap this, wrap these, put extra green down there. Did this Captain tape just to protect, because we do have a battery hot, straight to battery hot going there. So I did like quadruple protection there, so those don't touch. No, in the eventuality that somehow this pack ends up on its head, upside down because of a crash, everything should still be okay. So yeah, definitely the hardest pack I've ever done, just because of having to shove everything in such a small space. I say that with every pack, that this was the hardest pack. This was definitely the hardest pack. 1 tip, 2 tips. Like I said before, definitely on your plate for B+, solder that before welding it onto the pack, saving from overheating, and at least do your solder pads on the B-. And you can do the same thing actually on the connection too, to at least do your solder pads to avoid overheating. Also, before doing the fiberglass sheet and doing the paper, put your probe in, because now I've got to figure out how to shove it in there, because I just thought of it when I'm doing the BMS. Much easier to do the probes attach before everything is together. Well, it's truly the moment of truth, how she fits in there. Here's my lid. Should be okay. I'm seeing if I have room for one more FRP piece under there. Okay. Did the hole for this. Got it in the correct position, screwed in there. Got everything pretty much taped up correctly. Made internal handles because there's not really any space to do an external handle unless I had them attached on the outside, which would look ugly. So this way, at least if I need to, when the box is in the bike, I can get the pack out. Just have to take the top off. Got the top cut for the opening there, but unfortunately this stuff kind of can crack easily if you cut it against a grain. So I made a little crack in it. I'm gluing that, letting it dry up. And that's it, but I'm not gonna put in the bike yet because I'm gonna get try a couple sheets of 0.5 millimeter and 1 millimeter rubber to put on the bottom, just to give a little cushioning, because I should have space, on the inside. First little charging test, hopefully going okay. Final version of the cover is here, and working on a gasket to go there, help with water sealing. Okay, got the screw holes drilled relatively even, gasket made, hopefully will help, and 1 millimeter rubber on the bottom. I added strapping tape across the bottom and a 1 millimeter layer of rubber, just to protect hopefully the bottom a little bit better, make it stronger. Sorry for the horrendous background. And that almost is it. Gasket sticking out a little bit there. No, not done yet, because I'm waiting for the mini fuse with 14 gauge wire to come. I did find mini fuse locally, but it's 18 gauge wire, it's too thin. So waiting for that to come from US so I can do the fusing for this. And then obviously have the silicone there too, but for now, until those come, she's done. Okay, that's how it looks for now. And it works. Good news. Oh, that's how it looks. Yeah, I understand it's redundant that we have voltage on the egg rider too, but I think, since I haven't used the bike yet, I think the egg rider display can change. We can have something different there, maybe watts or amps. Well, for now I'm going to keep this here. We'll see if I decide to keep it permanent. I just did double-sided sticky tape, so I like it for now. And just like that, she is in. Thank God, cable length worked out okay. No, for now it looks okay.